Active circuit is defined as the circuit in which at least one active element is present in the circuit. Active elements are voltage voltage sources or current sources for this course. Okay. What is passive circuit then? A circuit with only passive elements. Passive elements means energy consuming elements. Resistors, inductor and capacitor also passive, even though pure inductor and pure capacitor never dissipate energy, they will store energy. These elements are passive because they cannot produce any energy or power on their own. The elements which cannot generate power or energy on their own are defined as passive elements, and circuit with only passive elements is called as passive circuit. Okay. Active circuit, at least one element should be active. One element should be active means in our course, source, either voltage source, battery, or a current source must be present in order to call the circuit as active. Okay. Let's look at this circuit. Okay. What is junction? Wherever the current division takes place, that is called junction. See, the current here is I1, let's say current I1, and current flowing through here is I2, and this one is I3. Current is dividing at this point, so this point is a junction. Okay, that point where current division takes place is a junction or node, otherwise it is called as node. Node and junction both are same. Similarly, C is also a junction, point C. D is not a junction because current is not dividing here. Okay. Similarly, F is a junction, G is a junction. Okay. What about branch? Each circuit element is can be told as branch. Any element, take this element DE, it is a branch. CF is a branch. BC is a branch. BG is a branch. Okay. Similarly, each circuit element can be defined as a branch. Loop means it must be closed. For suppose if you take this one from here to here, then this is closed, right? If you take closed path A B G H A, it is a loop. Okay. Similarly, you can take B C F G B. Similarly, C D E F C. These are loops. Why to take in this way? You can also take a larger loop like this. Okay. You can define that loop as A B C F G H A. This is also a loop. Okay. Any closed path in a circuit or a network is a loop. Okay. KCL is Kirchhoff's current law. As per this law, the algebraic sum of the currents meeting at a junction or a node of a circuit is 0. Okay. In this example, this node is labeled as A. Here, algebraic sum of the currents must be 0. Okay. It can also be defined as the sum of the incoming currents is equal to the sum of the outgoing currents at a junction or a node of a circuit. Okay. If you take outgoing current as positive, this will be I1 plus I2 plus I5. These are outgoing currents. The incoming currents are I3 plus I4. So we can also write it like this: minus I3 minus I4 equal to 0, or otherwise incoming currents equal to outgoing currents. I3 plus I4 are coming towards the node equal to the currents flowing away from the node are I1, I2, I5. So equal to I1 plus I2 plus I5. Both these equations are one and the same. Okay. This is KCL. Now let's define KVL, Kirchhoff's voltage law. According to this law, the algebraic sum of the voltages in any closed path must be 0. Okay. Otherwise, it is also defined as the sum of the voltage drops, potential drops, plus the source EMFs in any closed path of a circuit is equal to 0. Let's apply KVL in this loop A B G H A. I1 is flowing in the direction of the branch, so taken as positive I1 R1 plus this current is I2, so I2 also coming in the direction of the loop, so it is also positive I2 R2 voltage drop I2 R2. See, negative terminal is encountered first, so minus V equal to 0. Okay, let's take problem number 1. This is first problem. We need to find out each branch current. There are 3 branches, right? We need to find out branch currents using branch current method. How many loops are there? 2 individual loops are there, so 2 currents you have to take. So either you take I1 here, I2 here, this current will be I1 plus I2, or otherwise you can take I1 plus I2 here only. The current flowing here, you can take it as I1, this current as I2. I1 plus I2 is coming here at this node, it is dividing. I1 flowing towards 20 ohms, I2 is flowing towards 4 ohm. Okay, now let's apply KVL. Let's label the circuit A B C D E F. Applying KVL in the loop in a closed path A B E F A. 3 into I1 plus I2, current is flowing towards the loop direction. This is the loop. Okay, here also current again flowing towards the loop, so plus 20 into I1. Negative terminal of the battery is encountered first, so minus 100 volts equal to 0. So this will be 3I1 plus 3I2 plus 20I1 equal to 100. 3I1 plus 20I1 is 23I1 plus 3I2 equal to 100. Okay, this is our equation number 1. Let's apply KVL in the another loop. Let's take this loop in this direction. Okay, so let's define loop as BCDEB in a closed path BCDEB. Applying KVL in the closed path BCDEB. 4 into I2 because it is also coming in the loop direction. Positive terminal of the battery is encountered first, so it will be 110 volts. Current is flowing. See, the loop direction is from bottom to top. Current I1 is flowing from top to bottom, so you have to take negative sign. Minus 20 into I1, potential drop across 20 ohm equal to 0. Okay, otherwise minus 20 I1 plus 4I2 equal to minus 110 volts. This is second. We need to solve these two to find out I1 and I2. Let's use Cramer's rule to solve the problem. Okay, we can take this one as okay, take equations 1 and 2 or write them in the matrix form. 23 3 minus 24 I1 I2 equal to 100 minus 110. Okay, so delta will be 23 3 minus 24. The determinant of the matrix, this matrix is delta. 23 4 is 4 3 is 12, 4 2 is 8, 92 plus 60, so 152 is delta. So this is delta. We are using Cramer's method to solve the problem. We have written the equations in the matrix form like this: 23 3 minus 24 I1 I2 100 minus 110. Determinant of the main matrix is delta. Delta 1, you need to remove column 1 from there, and you have to place this at the column 1. Delta 2, you need to remove second column from the main matrix, and you have to place this 100 minus 110. Now I1 is delta 1 by delta. Delta 1 is 730, delta is 152, 4.803 ampere. I2 is delta 2 by delta, so minus 530 by 132. Negative sign accounts for reversal of current direction. That means current is not flowing in the assumed current direction, it is flowing in the opposite. Okay, that is what negative means. Minus 4.015 ampere. Small mistake here, the denominator should be 152, not 132. These are I1 and I2, so we need I1 plus I2 also. I1 plus I2 is 200 by 152, turns out to be 1.316 ampere. So we found out the branch currents using branch current method. Let's meet in the next session with new unit. Okay, thank you.